Welcome back to another exciting chemistry lesson. In the previous lesson, we have learned how to use conversion factor in chemistry that allows us to convert from grams to mole, or we can use it to measure from molecules, atoms, or in general term, representative particles to mole, or even all the way to grams. Now, that allows you understanding the unit mole. If we look at this flow chart right here, this flow chart is somewhat cut off over here. That's because this half right here is the same as that half, except for the chemicals change from A to B. What does that tell you about the unit mole? Well, the unit mole right here is considered as the centralized unit. Well, the word centralized, think of the word center, because the unit mole is the centralized unit of all unit that you see here. Basically, if you convert from one unit to the unit mole, you are now able to convert to any unit of your choice based on a given condition. For example, if I have atoms of anything, I convert to mole. Now I can convert to volume with the condition at STP, volume of gas, or I convert to grams, or I convert to volume of a solution, or I convert to energy. So that's the reason why the unit mole is so important, because it allows us to quantify not only substances in terms of atoms, mass, volume of gas, or volume of liters, but also in terms of energy, and also allows us to convert from moles of A to moles of B, which is essential to understanding how chemistry works in real life. Now let's look at this. Let's define what is a unit mole. Well, the unit mole, think of the unit dozen, okay? When you think of the unit dozen, it's equal to 12 items. But the unit mole is also equal to a very specific number, but this number is extremely large. Why is it extremely large? Because we are trying to measure a very small, very tiny particles like atoms and ions. We don't see those. And that makes sense because those substances are so small, we have to use a counting unit, which is what a dozen is. It's considered as a counting unit. We use that unit to count substances. In this case, the unit mole is a counting unit. That is equal to what? 1 mole is always equal to 6.02 times 10 to the 23rd. And this magic number is discovered by Avogadro. And Avogadro number, which is named after the scientist who discovered it, is basically 6.02 times 10 to the 23rd. So Avogadro is equal to 6.02 times 10 to the 23rd. Now let's look at unit mole, which we just look at the conversion factor. It can be converted from mole to particles, which is what? Atoms. Okay, the best term is representative particles. Atoms, ions, molecules, and so on. Or we can convert mole to number of grams. And we learned that using the PT, which is the periodic table. Or we can use that mole equal to 22.4 liters of A. And this is standard temperature and pressure. So what's the volume of a gas at standard temperature and pressure? And the same strategy apply. Take your given, time the conversion factor until you get the calculated answer. Now let's solve the problem. At standard temperature and pressure, why is that important? Because when you are doing your experiment at STP, you can now use that conversion factor. But does that mean we are going to use it? Well, it depends on the question. How many grams are in 3.7 moles of water? Well, we're looking for grams, which is mass right here. We don't really need STP. So in this case, our given is 3.7 mole of H2O. And what is the conversion factor between moles and gram? Which is right here, isn't it? How do we figure out the number of grams? Well, we use a periodic table. In this case, we have 1 mole. I'm going to write out 1 mole of H2O equal to the number of grams of H2O. Well, let's look at H2O. H2O, we have H2 times, well, what's the mass of hydrogen? 1.01 equal to 2.02. And oxygen is 1 times 16.00 equal to 16.00 for the total mass of oxygen, and you add them up, we have 18.02. So if that is a conversion factor right here, 18.02 grams of H2O, look what happened. The same thing we did before. We timed the conversion factor to convert from gram to mole. Well, if this is mole, this right here must be 1 mole as well. And that's coming from here. If this is on the bottom, the top part must be 18.02 gram of H2O. And there you go. And now we just plug this into a calculator. Multiply everything on top, divide everything on the bottom. 3.7 times 18.02 and divide by 1, which we don't really care. In this case, what do we have? In this case, our answer is 66.67 grams of H2O. And notice how I don't really care about those two conversion factors, because we asked for gram. Let's try another problem. At standard temperature and pressure, how many molecules are in 3.7 moles of water? It's the same question, but I just changed one word. Molecules. So now I don't care about grams, but what I care is about molecules, which is this conversion factor right here. And look at that, we don't have to solve for anything. So as always, take your given 3.7 mole, right, which is given to you right here, of H2O, time, well, what's the conversion factor? Right here. Replace A with H2O. That's just the chemical formula. So if that's the case, what's going on the bottom? Well, this is mole, so down here must be mole of H2O, and the top part must be the leftover, 6.02 times 10 to the 23rd. Remember, times 10 to the 23rd. Well, in this case, times 10 to the power of something is equal to E, and that gives us what? Well, before that, molecules of H2O. The mole cancel out. We just plug into a calculator. Now, because we are dealing with exponential number, we have to use the decimal calculator, specifically scientific calculator. In this case, 3.7 times 6.02, and then that being timed to 10 to the power of 23, and divide by 1, which we don't care. And that turned out to be 2.227, well, that round to 2.23, because of that 7 make it 2 to 1. So we have 2.23 times 10 to the power of what? 24 molecules of H2O. And if we type this on Streamlit, it would be 2.23 E24 molecule of H2O, because that E right there is 10 to the power. Now let's try another problem. The same thing, at standard temperature and pressure, how many moles of water are in 3.7 liter of gaseous H2O? Oh, look at this. So our given is liter of H2O, and notice how gaseous H2O, and this is standard temperature and pressure. Well, what does that mean? Because standard temperature and pressure, now we can use that conversion factor. So in this case, what we have here is 7.5 liter, okay, of H2O time, what is our conversion factor? Well, look at that right there. 1 mole is equal to 22.4 liter of H2O. I'm going to write it out here. 1 mole of H2O is equal to always, okay? That's the beauty behind that conversion factor. It's a fixed constant value. It's 22.4 liter of the chemical, which in this case is H2O. So we've multiplied it. And in this case, this is liter right here. So this part will be on the bottom. So 22.4 liter of H2O. What's on top? Well, on top would be 1 mole of H2O. And look what happened to the liter. It cancels out. And now we just plug into our decimal calculator. 7.5 multiplied by 1, which we don't care, and divided by 22.4. And that gives us what? 0.334. And that will round to 0.33. So we have 0.33 mole of H2O. And that is how we use the conversion factor from mole to liter. So as you can see, different problem based on the given and what you are looking for, you will be using different conversion factor. So be very careful on which conversion factor you use in order to solve for your desired unit.